Good morning, good afternoon, good evening. Today I will show you how to solve the problem number 16.72 in Pearson. This is a motion analysis problem, and I will show you just how to find all the velocities of this system. Okay. If you want to see the acceleration, maybe in another video, that's another topic. So first thing you have to notice, there's two bars. So we have the bar BDA. Let me draw it, that's correct. So always remember 1 bar equal 1 omega BDA. This is a B, and 1 IC, the IC BDA. Okay, and we have a second bar that will be the bar CDE. So this is 1 omega, that is different than the first bar, and 1 IC, and same thing, the location is different. Okay, so what do we know? And my color code is always blue, we know, red, we don't know. So what do we know? The only thing that is given is the velocity VA. And after that, we have the dimensions and the angle and all of that. You can notice just there that I made the system in SolidWorks. It's just a sketch. I made the two bars. I put the angles on both sides and the distances. I will use that to check my distance from IC after. I will show you how. This is just a sketch. I highly recommend to compare your answer that we will find by hand with the different geometry and laws. And if you can, do a CAD to check those things, that will be great. So the only thing that we know is VA. So we know velocity on VA. So we will start to work on the bar BDE. BDE. Okay, that will be our step number 1. So let's draw the bar. Oops. B with the pin connections, D and A. So again, we know the velocity VA. Oops. And I want to tell you, I will not solve anything. I'll just show you how to solve it. I will not find any data. That's way too long. What else do we know? If we look at the bar, we see that the little slider B, it's stuck in a horizontal tunnel. So we know that the velocity VB is either left or right, but it's horizontal. To find the IC, we draw line perpendicular to the velocity. So perpendicular to VA, horizontal, perpendicular to B, vertical. This is the IC of BDA, of the bar BDA. What we deduce from that? We deduce that the omega, because VA is down, we deduce that the omega will be negative in that directions. Okay, so we have VA. Let's find some distance. Remember the formula for the velocity with the IC? V equal omega R. That's it. That's the only formula that we have for the velocity. So we will start with point A, and we will use VA equal omega of this bar, BDA, time R, point A, to the IC of BDA. So what is this distance? This distance, what do we know in this formula first? We know VA. Oh, I try to put it blue. Oops, I will do it this way. We know VA, and for now, we don't know omega, and we don't know RAIC. We need one more information with one equations. So let's find, first steps, let's find RAIC. So RAIC is that distance, this one, RAIC. And how do we get this distance? We know this distance BA, and we know this little triangle 3, 4, 5. So on the drawing is writing 3, 4, 5 like this. Okay, 3, 4, 5. You can rotate this triangle twice, so 190 degrees, and you will have 3, the 4, and the 5, like this. Oh, I put a mistake, sorry. 3, 4 was, what did I did? 3, 4, 5. So I switch, this one is there, 3, the 3 is in the opposite side, 4 is now the downside, and 5 is the hypotenuse. So I have a triangle inside of 3, 4, 5. So for RIC, your R, oops, find RC, let me put it to the right, let's be organized. So find RIC, RAIC will be the distance BA, the hypotenuse, and this is parallel to the distance to the side that is 4, so time 4 divided by 5. So now we can find VA. So we have now this one that is blue. Let me try to make it blue. Oops, now this one is blue. So now we can find, so that will look the steps A, steps B. Now we can find omega BDA, that is equal to VA divided by RAIC. And again, that's the IC of just BTA. So now we know VA is provided. We found RAIC with the formula, with the geometry, and we will be able to find omega BDA. And we love that because omega BDA is the same for all the points on the bar BDA. So very convenient. Step 2. Okay, I will move my little triangle there so I have a little bit more space. Let's move it there. Try to stay one step below another. Step B. Step number 2, we will go at point B. I think point B is easier to do than point C. So let's go at point B. We are at point B and we want to find VB equal omega BDA time RB about the IC of BDA. Okay, now we are at point B. Okay, so what do we know? Now we know omega BDA. We found it before. We need to find RBIC. So step number 1, we have find RBIC, and RBIC is this side, and that will be BA times 3/5. This is this side of that triangle. So this is parallel to the side that is 3, so this is 3/5. Now that we have RBIC, this one is blue, and we can find VB with the formula omega BDA time RBIC. And we have VB. So now we found VB. And I can change on my drawing that VB, now we know it's to the right because that we know omega is negative. So VB has to be to the right. We have one more point to look at on that bar. So let me remove this triangle outside. Okay, we need some space. Oops, that's okay. Number 5. How do we find the distance? Which distance do we need and what's the direction of VD? What do? We go on that drawing. We draw a line from the IC to D, and VD will be perpendicular to this line. So I have a little right triangle there. Okay, great. But we don't know RDIC. We don't know this distance. We know omega, but we don't know RDIC, and we try to find VD. So if we look there, we don't have right angles in the triangle that we know. We will get in that triangle. Okay. So let me draw that triangle by itself, and let's work on that. Step number 3, point D. So the formula will be VD equal omega BDA, oops, time RD about IC. But right now we have unknown for VD, unknown for VD. So we try to find RDIC. So we are in that triangle. Oops, let me clean that. I will do that triangle a little bit bigger and just that triangle. This is point D. This is IC. This is point A. Okay. What do we know? Blue for no. We know this one, RDIC. We know AD. The distance are provided in the instructions. You see this one. That's DA. That's this one. Okay. And we also know we don't really know it, but we can find this angle. Let's call that alpha, because remember that little triangle, 3, 4, 5. So this one, we have alpha that is equal to the, oops, my little triangle, 3, 4, 5. So a tan of 3/4. So we can find alpha. We can find alpha. This is great. We have alpha. So we have this angle alpha. We have two distance, one angle, and we try to find one more distance. This is not a right triangle, so don't try to use trigonometry. Don't try to use the Pythagorean theorem. We have two options. We have two options in any triangle. We have option 1, cosine law. Cosine law will use three distances, one angle. So we can have either two distances, one angle, and try to find another distance, or three distance and not the angle and find the angle. We have the sine law, or law of sine. So law of sine is two distances, two angles. So to use this formula, we need to have two distances, one angle, or one distance, two angles. Here, we just have one angle and two distances. Look like the cosine law is the best one. So for point D, the step A will be to find RDIC with the cosine law in the triangle. So the triangle is ICDA. That makes sense. We have the distances and A. This is how you find the DIC. After that, when you have DIC, you just plug in the formula to find VD. So VD equal omega BDA RDIC. So now those two value, omega BDA is still the same, RDIC. You just found it with the cosine law. You can find your VD. Okay, you can find your VD there. I highly recommend to use the CAD software again and check those distance, because what did we find? We find, let me put in real, we found RBIC. What we get to find? We find RAIC, we find RBIC, and we find RDIC, all those distances. If we made a mistake on them, everything is wrong. And usually the mistakes spread on the next step with this method. Okay, because we already need the previous data for the next questions. So what I did is like, I went on SolidWorks again. So I draw these lines, the distances, the angle. And this is my bar. This is my bar BDA. I draw the perpendicular line to the velocity VB, perpendicular line to the velocity VA. And I found the IC. And I draw the line from the IC to D, this one. And I use driven dimensions, because anyway, those lines are horizontal, vertical, so we cannot move them. We cannot change their dimension. So I use driven dimension. So if you put the dimension and ask you, hey, do you want it to be a driven dimension? Just say yes. And I have the answer there. BIC, DIC, no, AIC and DIC. So check that you have the same value by hands and in a CAD software. That will avoid some keep going and having a mistake. We are done with the bar BDA. We are done with the bar BDA. Let's go to the next bar. We will go to the bar. Oops. Okay, I try to keep the same size of font. Here we go. So now we will go to the bar CDE. CDE is this bar, CDE. Okay, let me draw this bar. Oops. C, D, and E. And you have the exact distances. And we know also for the bar CD, we know this angle there. Okay. Right now, if you look at it, we don't know a lot. But there is a point that is on the two bars. This is the point D. So we know the direction of the velocity VD, this one. Okay? We know the direction of the velocity. Oh no, let me remove that. Here we go. We know the velocity of VD. So we know that VD was, let's say something like this. I'll put it a bit more. VD. So we know that, oops, we know that the velocity, the IC, will be somewhere on that line. I draw a perpendicular line to the velocity VD. Okay, one information. We need to grab more information. What do we have if we look at these instructions? We know that the slider C is stuck in a horizontal path. So C, we don't know if it's right or left, but we know that VC is horizontal. So we can draw a line perpendicular to VC, and this point is the IC of the road CDE. Okay, make sure that you draw your velocity like where you know something. At E, we don't know anything. We don't know if it's right, left. The point E is free to move in every direction. So that's what we know. So let's write step one. That will be step one for the road CDE. I can put that step four. Step four. Let's use the point D again, because that's the only place where we have any information. We have the formula VD equal omega of the road C. Oops. Moved on. How do we get that back? Okay, here we go. Omega CDE dot RD about the IC, and this is the IC of CDE. What do we know? The only thing that we know is VD, because VD is the same than the VD of the previous bar, because that's the connection between the two bars, the pin connection between the two bars. Okay, only thing that we know. We need one more information. We cannot find omega. We need to find R D I C. We need to focus on this one. So we need to find this distance there. Okay. To find this distance, we will get into that triangle. There's not a lot that we know. We will get in that triangle. Let me draw that triangle a little bit bigger. Okay. Point D, point C, I C. What we try to find is this one, R D I C. The only thing that we know there, we know this distance, CD. It's given. So we know CD, that's it. We cannot find the CIC, IC, or the DIC, like those two distances, like we can't find them just like this. We need some angles. We need some angles. Okay, can we find some angles? On the instructions, we know that angle there, the 30 degrees. So this 30 degrees, oops, I'm clicking on the wrong one. That's 30 degrees is there. So we know that the total angle there is 120 degrees. One angle, one distance is not enough. We need one more angle. Maybe we can find this angle there. Let's draw it. Let's call that. Do I already have an angle beta or not yet? Let's call that beta. We need that angle beta. And that angle beta is the same than this one, angle beta. And we know a lot in that triangle. We know alpha, we know all the distances. So we can find beta. So here, you step number one, let's call that step A, is to find beta in your triangle, in triangle, this triangle, the triangle of the cosine law. So the IC of B, DA, D, and A. And to find this beta, we can use the sine law. This is easier when we try to find the angle. So what do we know? We know that sine beta divided by the opposite side, dA, equal, let's say using the sine alpha divided by the opposite side, that was the the IC from BDA. Okay, so these steps is on bar BDA, on the previous step. Now that we have beta, so we know that this one is 90 minus beta. Okay? We have two angles, one distance. Step B, let's find RDIC, the IC of CDE. And how do we get this one? We will use a sine law, using sine law in triangle IC of CDE, C and D. So we can write that RD about IC divided by the sine of 120 degrees, if your angle is 30, it's equal to CD, because we know this distance is provided, divided by the sine of 90 minus beta. So now we have RD about IC. Now this distance is a blue distance. And we can find step number C. So this is still to find the omega. We can find omega CDE using VD equal omega CDE RDIC. So we know VD, we found it with the previous bar. This is the same. We know RDIC. We will get omega CDE. That's a long step, but we need to find the geometry. We need to find the distances. No choice. That is for the point D. Let's go to the point C. So point C is step number 5. Point D, point C, sorry. Point C. So the formula will be VC equal omega CDE time RC about IC. We don't know RC about IC. We don't know VC. The only thing that we know is omega CDE. So let's find RC about IC. RC about IC on our triangle is that distance. Oops, this one. I think the easier thing to do is to find that angle, and we will need it later. So let's find that angle. I will call that angle gamma. So step number A, you need to find the angle gamma, and gamma is equal to what? It's equal to 180 of a triangle minus the two other angles. The two other angles are 90 minus beta, and the other angle there is 120 degrees. So you find gamma. With gamma, you find RCIC. RCIC. I recommend to use sine law because we have all the angles. So you use sine law. So that will be something like RCIC divided by the RCIC is this one. So divide by the opposite angle, sine gamma, equal, let's say, CD divided by sine 90 minus beta. And with that, you find RCIC. So now RCIC, it's blue, it's a non-value. And let's make it blue. And you can find, so we are there, we can find the VC going to that directions because we know that omega CDE is negative. We are rotating around the IC. This is my VC. So we find VC with this formula. VC equal omega CDE time RC about IC. We are almost there. We are almost there. We get point C, point D, point C. We are just missing point E. So how do we find the velocity of point E? We draw a line from the IC to E, and VE will be perpendicular to that. So what do we need? We need that green distances, RE about IC. Okay? How we can find that? Let's go into that triangle. IC, D, E, this one. Okay? Let me draw that triangle by itself. So we are step 6, point E. We try to use the formula VE equal omega CDE RE about IC. We know omega CDE. We need to find REIC. So my triangle, let me check. How does that look like? Boom, boom, boom. IC, DE. What do we know? We know DE. This is given in the instructions. We know RDIC. We just found it before. RDIC, that will be this one that we found at the step 4B. This angle, way too difficult to find. Way too difficult to find. And I say way too difficult. I don't even know if we can find it just this way. I don't think we can. So let's check this one. This angle there. Remember this one? So this one CDE, it's a road, and we found gamma. So this angle we know this is the angle gamma. So the angle at D will be 180 minus gamma. So what we can do, we have one angle, two distance. We can find this. We can use the sine law. Okay, let's try to write it a little bit. 180 minus gamma that you found before. So first find REIC using sine law in the triangle IC of CDE, D, and E. So we have REIC divided by the opposite angle. That's sine of 180 minus gamma. That is equal to, oh, no, wait. We have just one angle. And we try to find distance. We need to use the cosine law. Sorry. Cosine law. We need to find this distance. We have the opposite angle and the two distances. So we will have REIC square, that is equal to distance DE square plus the distance RDIC square minus 2 times DE RDIC cosine of the 180 minus gamma. Take your time to do all those formula. It takes long time. So now we find REIC. We can do our very last steps and find VE, that is equal to omega CDE times REIC. And now we know omega CDE, we know REIC, we can find VE. And that's our last step to find VE. This method doesn't give us a direction, it gives us just a magnitude. One little check, go on SolidWorks. So what I did is like, I have my, this line was the IC to D. I went in on the bar B, D, E. I draw a line that is collinear to this one with the IC, but longer. I draw the vertical line. This is my IC. And I draw the line from the IC to E. Look like this. And I use driven dimensions, and I found the value of, so everything that we need. This one is the RDIC, is this one. This one is the RBIC. And this one is, this long one is the REIC. So it's give me a good way to check the different dimensions. Highly recommend it. So let's summarize a little bit all those steps. Where are all those steps? There. What we did is we did the bar BDA. And it's super zoom in, so I will try to do a bit bigger bar BDA. We have VA. We found omega BDA. We found VB. We found VD. We switch to the bar CDE. We use, so what do we have is that we have VD. We use VD to find omega CDE. And we found VC and we found VE. Of course, to find all of that with the IC method, we need all the distances from the IC. We need to find the location of the IC and find all the distances. So that's it for this video. I hope that helps. Let me know if you have questions in the comments. Bye-bye.